What's up, guys? Today we're going to be talking about SWOODboxes. We've gone over a couple different elements in SWOOD. The first one being SWOOD frames, as well as panels and materials. So the next progression in your SWOOD arsenal would be the SWOODbox. So yeah, let's go ahead and just jump right into it. So as you guys can see here, we have our SWOODbox tab. And what a SWOODbox is, it's basically a more dynamic insertion of components and machinings. Good examples of what could be included in a SWOODbox would be shelves, hinges, door fronts, drawers, pretty much like the internal components that would be encompassed into the frame. And the nice thing about the SWOODbox is that they are super dynamic and editable and very repeatable. So you could use this function for several different frames, which is nice. Let's go ahead and just create our and jump into the SWOODbox environment, and I can better explain basically what we're working with. So inside here, actually what our plan is to do is we're going to create a SWOODbox for one of our frames that we created previously. So maybe I could start with opening that up first. So in our frames tutorial, we created this top, this bottom, left side, right side, and we added a back and a shelf. And what I want to do is I want to create a SWOODbox that inserts a back rather than creating it as a frame. And the reason for doing that is because some people, when they do their backs, they don't have necessarily like this butt joint like they would like to do a dado that their back inserts into like each side of the panels. Whereas this one, as you can see, is just a typical old butt joint. And the reason why the SWOODbox is a great candidate for that is because you're able to integrate machining into your SWOODbox, and it's kind of attached to that panel location. So let's say if I wanted to move this back further into the box, or yeah, like if I wanted to move this panel forward and backwards, you have the capability to do that. And it'll start making sense as I pretty much create the element, drop it in, and you guys can see what I'm talking about. But to start off with, let's go ahead and we're going to close out of this frame. I'm going to start with our SWOODbox. So we're going to create a new, just like all the other SWOOD elements, and you have this drop down and you're going to select SWOOD/SWOODbox. So we'll click on that and we're going to rename it. So this box in particular, how I want it to look, I want it to be 1/4" material, and I want there to be a dado that 1/4" material slots into. And we're going to have what's called stretchers that help support that 1/4" material, because 1/4" is pretty floppy. Like if you touch, like pounded the back of the SWOODbox, or rather not the SWOODbox, but the cabinet, like it'll flex, and those stretchers allow you to have a bit more rigidity to that, and that's made out of 3/4" material. So that way when I go and tap on the back of that cabinet, nothing's going to be moving around. So we'll continue by creating our name for this SWOOD box, so I'm going to call it 1/4 inch, and we'll do underscore BK for back. And once that's created, it's kind of just stored there, so we have to edit it. And when I open my SWOODBox environment, I have a little bit extra planes than I did in my SWOOD frame library. So as you can see, you have the typical bottom, front, left, top, right, back. And if I were to illuminate all of these sketches, this is like the bounding box of your SWOOD frame. And we also have offset planes. And these are awesome because inside of your SWOODbox, you want to be like, have the ability to be dynamic and create an offset off of a plane if you need to. And we're definitely going to be doing that in this example. So as right now, I'll close out of these sketches, just hide them. And we're going to jump into our SWOODbox tab up here. So this is new. We haven't really jumped into this before because in our SWOOD frame folder, they don't have this little tab here. And this may look overwhelming, but actually it's fairly simple. So inside of this dropdown, you have parameters. So basically what these parameters are doing, they're controlling the components inside of your SWOODbox. And as you can see, there are already parameters controlling those offset planes, which were shown here in this dropdown. So these are all your planes, and these are all the parameters controlling those planes. So what I like to do, if I know that I'm going to be creating a SWOODbox that has an offset, I like to visually be able to see the distance between these planes. So as of right now, there is no distance. And like if I went to this is our left side. So if I went to our offset left value, that's set to 0. So what I like to start off with first is create that separation. So I'm going to make it 1 inch. So I'm going to make this exposed, and I'm going to come over to this test mode tab. So when I come over to this test mode tab, we have a rebuild button, and this is our offset left. So since I made that exposed, I can see that here. So if I went over to our offset right, made this exposed, jump back over, you can now see that in that test mode environment. So I made that left side 1 inch. So it didn't carry over, but we can go ahead and input that value here. So 1 inch for both. And as you can see, that left side offset has been created, as well as our right side offset, which is great. So I'll go ahead and do that for the rest of the components. We'll make that 1 inch, front 1 inch, bottom 1 inch, do back exposed 1 inch, this exposed. Awesome. And all those offset planes should now be exposed, and I can change these values. Let's do 1, 1, 1, 1. There we go. Now we can clearly see our offset planes. So when I drop a SWOODbox into a frame, basically the inside, let me think of a good way to explain this. Maybe the best way to explain this would be to drop it into space so you guys can see where these planes are. So what I'll do, I'll go ahead, close out of this SWOOD environment, and I'm going to open up my lower cabinet frame. And we can delete these components because We're not worried about them right now. Okay, so we have our frame. As you can see, it's just a carcass. We have our top, right side, bottom, and left side. And I want to insert this SWOODbox, this 1/4 inch back. I know there's no elements attached to it, but we can still insert it into our frame. So as you can see, there's this dialogue or this like little graphic that kind of shows like where things are being mated to. So that outside bounding box is being mated to the inside of our frame. And if I click on this, as you can see, like this dot is mated to the inside of this left side. This bottom dot is mated to the inside of that bottom panel, so on and so forth. So when I go ahead, insert that in, see if there's a good. And these are the planes associated with that SWOODbox. So as you can see, that left side is on the inside of this panel. And I can also show you guys that the sketches that were shown there. So like as you can see, it's kind of faint, barely see it, but the bounding box of my SWOODbox is on the inside of that frame. So basically what I want to do, now that you guys kind of know like where the SWOODbox will be inserted, I want my panel to dado into the top side of that, to dado into the inside of the frame. So to do that, I want my offset planes, rather than going deeper inside of the box, I want it to go inside of the box. So all of these offsets, I want to switch their offset. Because if I kept it like this wouldn't dado into the box, but I do want to dado into the box, so I'm switching that offset, and that'll allow that panel to do so. So I'm going to do that for the bottom, the left side, right side, and top. So let's go ahead and do that. So offset right side, flip offset. We're going to do offset left, flip offset, and finally, for the top one, we're going to flip offset. Cool. And further back, we want that offset to stay as it is, not go to the outside, because if I flip this offset, then that back panel would be oriented outside of the SWOOD frame, which we don't want. So now that we've done that, we're going to jump over to our panels library, click on that, and I actually already created a 1/4 inch MDF panel. If you guys aren't familiar with creating these panels and materials, I recommend you jump back to the videos that I have just outlining how to create that. Yeah, they'll direct you on how to do that. So I'm going to insert a copy, click on this new panel position, and I'm putting it back, so I'm going to drop in this back. So I have to be a little bit careful on where I drop this into. So, or like where I mate these planes for my panel. So rather than mating it to the top, I want to mate it to that offset on each one of these sides. So as you can see here, not the right, I want that offset right. I want not the bottom, but the offset bottom, and I want the offset left as opposed to just the left. And our last degree of freedom is going to be this offset back, and I'm going to measure that value from the front of this panel. So I want the front of the panel mated to that offset back. So as you can see, I have all dots here. I can go ahead, accept that these are the mating relationships that I want by hitting the screen checkbox, and my panel is dropped into place. Great, so that's step one. So as you can see here, I have these offset values, and if I change any of these offset values, so let's say this offset top, I want to make that 5 inches as opposed to 1 inch. And I'm going to do it actually in our testing environment. So if I wanted to change that top 5 inches, when I do that, that top changes just like so. Here's that maybe this left offset, I might have made it to the wrong place. Oh no, we're good. So that's made it to the right place also. So I'm going to bring this back down to 1 just to show you guys how that moves around. So that's a nice part about SWOODboxes is that they're super dynamic in their like variables and how you control them, as opposed to frames where they're a bit more rigid and you have less ability to customize them once you've inserted them into your assembly. So what we want to do, I want one variable that controls each one of these planes because my data is going to be consistently the same on each side. So if I wanted to change my data to 3/8, if I change it in one place, it'll change all these variables at once rather than me having to go in and manually input that 0.375, 0.375, so on, so on, so on. Too slow. So what I will do, I'll jump over to my variables definition, and I'm going to create a variable. So you have a couple options for creating variables. You could do it by distance, angle. A string is like basically like how do you say, text pretty much. String is like if you wanted to like make a comment or use a comment to control a parameter, an integer, a boolean, decimal, so on, so on, and so forth. 9 times out of 10, I feel like I typically default to this distance value. The reason why I do this distance value is because I will oftentimes flip between using metric and imperial standards. And if I were to, let's say, create a parameter using a decimal point, it sometimes doesn't always translate well. And if I flip to a metric environment, it'll sometimes break my model. So I'm just going to show you guys the distance parameter to start off with. So what we're going to do, we're going to name this dado depth. The naming is mostly just a visual thing. The alias is what's important and what you want to change. I try to keep it consistent with this, the start of the name that I'm creating. So like for dado depth, I probably make this alias DD, and that's going to be like your variable when you go to program how you want this to behave. That's the alias that you'll use for that. And for our initial value, we're going to be manually changing this, but since we wanted to make that depth 3/8 to start with, let's go ahead and just make that initial value 0.375. And so great. That's basically all we needed to do on this front. So dado depth has been made as a name, alias has been changed to DD. That value is now exposed, and that initial value is 0.375. When I go to my test environment, I'm now getting like a lot of noise because I have my dado depth, but I still have all of my offset planes still visual on this side. So Pretty much the only one that I still want out here is this offset back because that's not going to be controlled by that dado depth. So when I come back to this screen, I'm going to select all the offset planes except for that offset back and just uncheck the exposed checkbox. So when I jump over to this test environment, I'm left with just the dado depth, just the offset back. We haven't connected the dado depth parameter to those other offsets. So if I change this value to something ridiculous like 2 inches, nothing is going to happen, as you can see here. Like this offset is definitely not 2 inches. This is 1 inch still. This is 1 inch, I believe. So on and so forth. And I think I set this initial value, I left that at 0, and that's why that keeps switching back. So let's look at that offset right. Yep. So let's switch that to 1. So yeah, I can change this again. Nothing's changing. So what I want to do is I'm going to go into this functions tab. And the functions tab is a bit more complicated, but if you have any background in programming, this will probably be like the easiest programming that you'll ever encounter. It's really simple. And if you haven't, just follow along. It's easy stuff. Don't be too intimidated by it. So basically, all of the variables that have been created are in this dropdown somewhere. So I think these are specific to our SWOODbox, and these are specific to SOLIDWORKS and our SWOOD. Okay, I take that back. So these are specific to our SWOODbox specifically, and these are specific to the SWOODbox like parameters definition. So pretty much everything that you've created here will be in this value, in this dropdown. And then everything that is information on your SWOODbox that was pre-created is going to be in this dropdown here. So we want to turn our attention mostly to this dropdown. And what we want to do is we want to make this top offset, left offset, right offset, bottom offset all equal to this dado depth. So as you can see here, we have our offset bottom, offset front, offset left, offset right, offset top. So these are the names, and then these are the aliases. So what we want to do is we're going to click on this offset bottom, and I think it's a double click. We're going to hit equal, and we're going to set that equal to our dado depth alias. So we'll double click that. And one thing that you should know in this function window is when there is an error in your code, your screen turns red. So if I were to delete that DD, your screen turns red, there's an issue, and you have an error code at the bottom. And it's like set without second member. What that means is you're trying to define this offset bottom variable. You have it set equal to nothing. That's an issue. When you have a red error code, you have to be really careful because the way that SWOOD operates, if you close out of this window, it'll delete pretty much all the contents within the SWOOD frame or within the SWOODbox. So you don't want to do that. You always want to be left with a white screen as opposed to a red screen. So that offset bottom is set equal to nothing. So when we click on this dado depth, that is now offset bottom is equal to dado depth. So what we'll do, we're going to do this for each one of those offsets. So offset left, we want that one. Offset right, we want that one. Offset top, we want this one. And offset from, we're not worried about for this example. So we want to do equal to DD, and we're going to copy and just paste that over. And when I do that, that dialog is now white again, and those values have been linked to that variable which we defined as data depth. We'll close out of this window, come over to our SWOODBox, and we're going to rebuild this. And boom! This is set to 3 inches. That's why it's so big. So if we set this to 0.25, everything changes along with it, which is great. Awesome. So our offset for our top, left side, right side, and bottom have been defined, and it's all being controlled by this one variable, as opposed to having to change each one of those manually. Our offset back, we want to keep independent because that's not controlled by this variable here. So if I wanted to make that offset from the back 1 inch as opposed to, what was it, 3/8, it's going to move forward that much. If I wanted to make this 5 inches, it's going to move that much. But we're going to keep this at 1 inch, 1 and a 16th. So 1 inch and a 16th. So we're going to do 1.06. Oh, that's 11. 1.0625. So we'll rebuild that, and that's living there now, which is great. Awesome. So we've done that, and what we want to do now is we want to apply machining to this. Because yes, our panel is doing what we want it to, but there's no machining associated with that. I can show you guys that in real time. So if I save this SWOODBox, close out of it, and I jump over to my frame again, and I drop in that SWOODBox, and I hit check. I'm like, oh, awesome, my back is inserted into the SWOODBox. But as you can see, it's kind of just inserted into that top panel. And if I do an interference detection, which I use a ton, I recommend you guys get familiar with this tool. You click on this value, and it's asking would I like to calculate these selected components. I'm like, lower cabinet, which is the overall assembly. I'm like, yes, calculate. And as you can see, there is an interference here, interference here, interference here, and interference here, which makes sense because we haven't added any machining. So I'm going to go ahead, delete that SWOODBox, and we're going to edit it again. Our machining is done in this machining definition. And inside of this tab, we want to click on this drop down, this machining definition, and these are all your options. So we can do new drilling, new compound machining, drillings driven by sketch, extruded cut, and these are just like copy and delete your definitions. So in this example, we want to create a dado. The dado is going to be controlled by a sketch. And we could start off with either creating that sketch first or creating the machining definition, which I think I'll start with doing the sketch. And so I'll click on our regular feature tree, our design tree in our feature tree. And I am looking to do a sketch on our top plane and our left plane. And yes, we are going to be doing a dado on all 4 sides, but really, since we're going to be mirroring over our machinings, we only have to do that sketch on one of each of those sides. So the top will be mirrored and it'll be done. The machining will also be done on the bottom, and then we'll do a sketch on the left, and that machining will be mirrored over onto the right. So let's start off with a sketch on our top plane. And we want to do that on our top plane as opposed to our offset top. And the reason being is because we want that machining to cut through the whole side of one. How can I explain that better? If I did the sketch on this offset top, basically the beginning of that extrude cut is going to begin at that offset top, and it's going to apply machining from that point. So basically you'll have, if I did the sketch here, we'll still have material between the top of that panel and to that dado, which we don't want. We want that dado to be completely clean. So we're going to do that sketch from that offset, or not the offset top, from the top plane. We'll do that, click on sketch, and we're going to normal to so we can see the top of it. And the way that we'll do that sketch, and this is just kind of from experience that I've had at previous jobs. Since this is a 1/4 inch panel, I'm going to make this extrude cut 5/16. So that way it's just slightly bigger than that 1/4 inch material. And I'm going to make this sketch coincident with this plane. So when I look at it from above, as you can see, our extrude cut is going to be cutting exactly in line with the front of our top panel, but we're going to have a little bit of offset wiggle room to get that panel into place. And then from here, I want to create an offset. And what we'll do, we'll make this value significantly bigger because we want that dado to run through the length of the whole panel. So we can do that. Let's do it from this right panel. And we're going to make this, let's do 1.5 inches, which is kind of big, but we want to kind of exaggerate our point here. We'll do the same here, so 1.5. And cool. When I'm looking back at that sketch, we are fully constrained there. So we have no blue lines left. So we're good to go. So sketch 1 has been created. So now we want to do a sketch on our left plane and pretty much do the exact same thing except on this face. So we're going to be looking at this side. Make this 5/16, 5 divided by 16. We want this and this on the same plane. We're going to do 1.5 offset from the bottom. Do 1.5 offset. That has been created. We now have our 2 sketches to reference. So from there, we're going to jump to our machining's definition, and we're going to click on our, not this yet. We're going to click on our extrude cut option. And basically, we're just defining what that extrude cut is going to do. So we're going to change the name, and we're going to do dado top. And we're going to make the depth 0.25 inches for now. But we have the ability to change that in the future, and I'm actually going to attach it to that same value as our like dado depth, if you remember with the alias dd. So it'll be dynamic to that change. So now, since we're looking for the dado on the top, this is our top plane. So we're going to click on that sketch. And cool. So that has been created. I want to then apply that machining to a specific side. So if I were to not choose a spot to apply that machining and I go to rebuild, nothing is really going to happen. The sketch is still there, but I don't see any machining. So you have to apply it to a specific face or a specific like plane. So I want to apply that dado top extrusion to the top side of the SWOODbox. So when I jump over and rebuild now, as you can see, this right here is our machining. So it's tied to our sketch, and that should be our 1/4" machining. And I know I made this offset 3/8, so maybe we could change that now. So let's do 0.375 inches, which is great. We'll go ahead, rebuild. May have to, since I made an edit to that. There we go. Weird. That is weird, huh? Not changing. I don't know exactly what's going on with that, but we'll go ahead and add our symmetry to the other side, and maybe that change will have its effect. Let's go ahead, rebuild that, and there is our offset there. Okay, I see what the issue is. So you can also control the dado depth on this dialog here in our test environment. And I changed what it will be default to, but in order to change that depth, I needed to input that there. So that all makes sense. So 0.375, 0.375, and as you can see, that is lining up now. So cool, great. We've created our top offset. So now I want to create our left side data. So to do that, I will go ahead and click on this top dado, and I'm going to copy over the machining. It basically makes a copy, and it's going to save like all of those defaults that I already created. Oh, and you know what? Before I do that, I'm actually going to delete this. Before I copy that over, I want to apply, I want to make this value equal to that dado depth offset. So in our machining definition dropdown, you have this button right here, and this is your functions button. So we can click on this, and right here we have very similar window to the function button for the variable dropdown. So basically we want to do the same thing that we did earlier, where we make the depth of this machining equal to the dado depth itself. So what we'll do, we'll double click on this P. It's equal to, double click on this dado depth. And the reason why there is this prefix to it is because it's in a different drop down in the SWOODBox component as opposed to like the machine library. So instead of it just being like DD, like if I did just DD, this isn't gonna, it's gonna have that red window, error, no signification for the word DD. So oftentimes, like if you're like, oh, I know I made that alias DD, look for it in this drop down, and oftentimes like there could be a prefix associated with it, and see, no red window. So I have my dado, and I do want that machining to at least be the same depth as whatever that offset I'm going to make that panel. But I also want to give it a little bit of wiggle room so that way like that dado isn't, or that panel isn't like smashed into that dado. So what we'll do, I want to add 1 millimeter. And the way that the SWOOD library or the SWOOD functions work, pretty much you always have to put your values in millimeter as opposed to inches. I've had it several times where I'm like, because I'm from the US and I'm used to the imperial standard of measurement. And I'll like go to create a function and I'm like putting in 1 inch and my SWOODbox or SWOOD frame is not acting the way that it should be. And I'm like, what is going on? Like, why is my function not properly doing what I want it to do? And oftentimes it's because the SWOOD function only looks at values like integers as metric as opposed to imperial and millimeters to be specific. So that one means 1 millimeter, and even if I put 1 inch there, I'm going to have an error, just the way that SWOOD kind of works. So if I did want to make this 1 inch, I would have to do like, what is it, 12.7 millimeters to make that 1 inch. So just food for thought. But right now, my offset, I just want it to be 1 millimeter, so I'm going to leave that +1. So great. So we do that. So awesome. Basically, when I jump into the testing environment, as you can see, our machining is just about 1 millimeter bigger than our offset panel. And if I were to change this to 0.5 for the dado depth, that machining changes along with it. So don't forget, we didn't copy over that machining over to our left side. We only did that for the top. So now what we're going to do, we're going to click this copy intelligent machining, click on it, and it's going to make copy. So let's change this to dado left side. And pretty much everything we can keep the same, and even the function carries over. So that's important. So now we're going to apply this to our left side. And when we go and rebuild it, oh, you know what? Oversight on my side, you have to change the sketch that's associated with. So sketch 1 was that top sketch. We want sketch 2, which is this left side sketch. So now when I go into the test environment, that's a change just like so. So boom and boom, perfect. Now we want this to be left side, right side, and as you can see, there is machining on the top bottom, but only on the left. So you can't forget coming over to this right side, clicking on symmetry, and then that machining is then applied. Awesome, this is great. We can go ahead and save that. We'll close out of this window and we want to test it into our frame. So we'll come back into our frame, click Insert, SWOODBox, and insert SWOODBox, just like so. Perfect, that's in there. Okay. And now SWOOD frame has been adjusted with those changes. And what I recommend doing is like hiding these sketches before you save your SWOOD frame. That way you don't have to hide your sketch every time you go and insert that into your frame. But as you can see, now when I do this, like that machining has been applied to all my panels. Perfect. Awesome. So cool. We've done that, but we're not quite done yet. So remember earlier when I was talking about this 1/4" material, it's pretty floppy. And like if I were to come with my finger and just tap on this space here, like that panel would be moving around, making a lot of noise. We don't want that. So we need to install stretchers, which are going to be pocket screwed into the side of this left side panel, right side panel, bottom, top, and then in between where the stretcher interacts with this back, or with this back, we'll apply some hot glue to keep that panel rigid. So yeah, we're not quite done with this SWOOD box. Go ahead, delete this. We're going to jump back into our SWOOD box, and we're going to add a 3/4" panel. Before we do that though, we need a plane that defines the width of our panel. So we're going to click on this and add a plane. And how I do that, I click on it. Well, I hold Control, click on it, and drag away, and it creates an offset plane. So we're going to want that width of that stretcher to be 4 inches. So we type in 4, and we're good to go. We can go ahead and rename this stretcher width. Come in, click on our 3/4" MDF panel, insert a copy, click on new panel position, and this is going to be towards our back, so we want to click that back panel. So as you can see, that's back there. We want the top, attach that stretcher width plane, bottom attached to the bottom plane, and then the right and left side just made it to the standard left plane, right side plane. And then for our, to made it to this degree of freedom, we'll click on this plane here, which is just the face of that back panel. And we'll go ahead and accept that as it's good to go. So as you can see, fully defined down here, and that panel can't be moved in space. So great, we have our stretcher in place, but we only have one. There's a neat tool called linear component pattern. So basically all this is going to do, it's going to make a copy of this and do a linear pattern up to a reference point. So we'll click on that, and we want our direction to be going this way because, yeah, we want to have at least 2 more stretchers, probably one at the very top and one in the middle. So we're going to choose our offset top plane as a direction. And instead of doing spaces and instances, I want to do up to a reference. So our reference, so basically where this linear pattern is going to stop is at this top plane. So as you can see, that then becomes top. And from there, I recommend everybody do these first two. Come down to the components to pattern and click on your whatever component you want pattern. In our case, the stretcher. And as you can see, there's like a ton of stretchers. And that's when I come back up to that direction 1 tab, and it's asking if I want to do bounding box center or selected reference, and then this is the distance at which that linear pattern is having. So basically what it's doing right now, starting from the center of our stretcher and doing a linear pattern every just about 2 inches. We don't want that. So what we want to do is instead select this selected reference, and now it's asking for which reference do you want your linear pattern to start and end from. So I'm going to select this guy here, and since we want to do 3, let's do 3. Okay, and this is kind of easier to explain when I'm at this view. So this face is the selected reference that we want that linear pattern to stop from. And since we made that top plane our like ending linear pattern reference, that face is going to end on that top plane. If I decided, I was like, oh, I actually don't want that face to be there, but I want it to be the top of this, or to the bottom of the stretcher. Like now you can see that that top plane and the bottom of that stretcher is now in line. Which obviously we don't want that for our SWOODbox. We want this top point, just like so. And 3 is fine. We can change this to 4. And what we're going to do, we're going to assign this to a variable in our SWOODbox setup. So we're good to go on that. Put that to 3, which is great. But I want to be able to control this. I want to be able to like go to my test environment and be like, oh, I want 3 stretchers, or I want 4 stretchers. So to do that, I need to create a new variable. So jump over here. And we're actually not going to use our distance parameter. I'm going to instead do integer. And integer is just a number without a decimal. So we're going to click that. And the new integer, we're going to call this number of str for stretcher. And then our alias, let's just do str. Apparently we can't do that. Let's just do st then. So initial value, we'll make that 3. And we want to link that value to what's going on in here. So I'm going to select driving. Driving just basically means that we're going to have the ability to control that from our SWOODbox dropdown. And I'm going to click on this area next to selection. This area turns pink. So oftentimes I have a hard time finding this little number, but if you double click on your local pattern, typically on the second instance, as you can see, there's a little tiny 3. So that's the number of instances of your linear pattern. So I'm going to click on that 3, and as you can see, that dimension 1 at local pattern, so that is now attached. So now when I come to this testing environment and I want to make that 4, I have 4 stretchers. If I wanted to make that 5, I have 5 stretchers. And the reason why those stretchers are just being evenly spaced in between those 2 endpoints is because of those reference points that we established in our linear component pattern. So those are definitely really important that you attach those correctly. And I probably explained that somewhat poorly, so I apologize for that. But yeah, so we have our stretcher. We have our machining for our SWOOD, for our 1/4 inch back, and we have the ability to control these, and you can also like reorder um, the way you want to see that. So I want to be able to control my dado depth. I want that on top, and then I want this offset on the back to be second, and then I want the number of stretchers to be third. And I also do want to make sure that I have that offset on the back set to 1.0625 because yes, this overall buildup of back plus stretcher should equal 1 inch, but I want to have a little bit of wiggle room. So just in case like things aren't exactly perfect, when I build my cabinet, I have a little bit of wiggle room so the stretcher isn't overhanging the back of my cabinet. So I made that 1/16 as opposed to 1 inch. And yeah, let's go ahead and test out our SWOODbox. So we'll go ahead, close this, come over to our frame, and we'll do our, we want to insert not our frame, but our SWOODbox. And go ahead, drop that in, and sweet. So, and also I forgot to hide those sketches in assembly. Good to see. Yeah, we have our stretchers in here. We have our SWOOD, or our back all encompassed in our 1/4 inch back SWOODbox. And if I right click on this and hit edit feature, that same dialog box that I created in the testing environment is then editable from here. So if I was like, oh, this specific cabinet, I need 4 stretchers as opposed to 3, I can come in, type in that value, and boom, those 4 stretchers are then inserted, and I'm good to go on that. Or if I wanted to change the dado depth, and I was like, 3/8 is too deep, let's make it 0.25 for a 1/4 inch, change that value, and we should be good to that. So like if I go and measure this value, this should be slightly over that 1/4 inch because we added that 1 millimeter of offset. And when we do our interference detection, and this is kind of moment of truth here, we should have no interferences. Boom, check that out. Good to go on that. So yeah, that's kind of just an overview of our SWOODbox, and yeah, hope that you guys are able to use this video as a reference point to start on your first SWOODboxes, and yeah, best of luck to you guys.